Okay, let's get started. Can you hear me at the back there? Yeah? Can you see the slides okay? Yeah, I know there's a bit of light, but hopefully you can see everything I'm going to be talking about today. Okay, so welcome. This is Demystifying Celery by myself, Sam Clarke. Originally, this talk was entitled Celery in Production. I've since widened the scope a little bit, so anybody who is new to Celery that's never used Celery before shouldn't get lost as we go through the talk. Okay. So if you came here expecting a talk on vegetables, you're in the wrong place. This is your chance to leave and go to a different talk. But if you did come here expecting a talk on distributed task queues written in Python, then stay here. This is the right place. Okay, a quick word about who I am. I work for a creative agency based in Vancouver, Canada, called Rival Schools. We build a lot of web applications using Python. I'm also lead developer on a product called Script Speaker, which basically takes movie scripts, turns them into casted audio files. And that's written in Python, and we rely heavily on Celery for that. Okay, so the reason I wanted to give this talk is based on my own experience getting started with Celery, based on experience of colleagues and what I've witnessed online, is that getting started with Celery, especially for new developers, isn't always a smooth process. There's some pain points, some pitfalls, some gotchas, and some areas that don't make a lot of sense the first time round. So the idea of this talk is to take some of that mystery out of getting started with Celery and getting up and running. Also, for new developers, it might be the first time they've been introduced to distributed architecture, and that's intimidating. Also, although Celery is written in Python, some of the underlying technologies and protocols aren't Python, and that can be a source of intimidation for new developers as well. Okay, so I'm going to give you a quick overview of what Celery is and how it works. We're going to dive into adding that to a Python application. We'll look at how you move from a development environment to a production environment with Celery. And finally, we'll have a look at how to log and monitor your application when it's running in production. Okay, so what is Celery? Celery is written in Python, obviously. Celery is a task queue. So what is a task queue? A task queue is a queue of work to be done that is executed outside of the user request cycle, which means work can be executed in the background when the resources become available to do that work. I must mention that Django Celery is also a useful package for Django specifically, but in this talk I'm going to focus just on the pure Celery implementation. So you're thinking about using Celery. The first question you should be asking yourself is, do you need to use Celery? If you have a very small application where that work is executed synchronously, then you may not benefit from having a task queue at all. However, if you have any work in your application that can be executed asynchronously, you can possibly see a performance benefit from using Celery or using any task queue. Also, if you're configuring your application to be performant and you don't have much in the way of available resources, again, you can get a good performance boost from offloading some of that work to a task queue. Bear in mind when you're introducing any third-party application to your application, any third-party tool, then you're introducing code that you have to take responsibility for. And that can add some complexity. So there's always this trade-off between getting performance boost, but also adding some complexity to your stack. Okay, how does Celery work? The first core concept of working with Celery is that of brokers and backends. And basically, a broker is your mediator between your Celery workers. And that communication is done via messages. The underlying protocol of how those messages work depends on which broker you pick. There's several options here. RabbitMQ and Redis are by far the best practice options to use. Celery was written with RabbitMQ in mind, so RabbitMQ really is the best fit for your broker, at least initially. Celery also takes a back end optionally if you don't think that you need to get results from your tasks or query your task state. Maybe you don't need to use a back end. But if you do want to get any task state or get results, you will need to have some storage mechanism. There's a variety of options that Celery will accept here. Memcached, any database, RabbitMQ again. RabbitMQ is not a good fit here. It's a task queue. It's not persistent storage, so don't use that. My recommendation here is to use Redis. And a quick word on what Celery workers and concurrency are. These are the next kind of two concepts to wrap your head around when getting used to Celery. So a worker is basically your Celery process. And one Celery worker can spawn multiple child processes. And it's these child processes that actually go to the task queue and do your work. You can specify the number of processes a worker can kick off, and that's the concurrency argument. You can do this explicitly. Celery will default to the number of CPU cores on the machine. There is an auto-scale feature for Celery. I've had mixed results, and I've witnessed mixed results online with using that auto-scaling, CPU spikes, etc. So our best practice that we found is to specify concurrency directly when we start the worker. OK, so that's a really brief overview of what Celery is and some of the core concepts with Celery. So let's have a look at how you would add Celery to your application, to your Python application. So you're going to need RabbitMQ server for sure. Optionally, Redis if you're using that as a storage backend or whatever other storage backend that you've decided to go with. In your virtual environment, you're going to install Celery. And then you're ready to import Celery and instantiate it. So very briefly, in the most basic configuration, you instantiate Celery. The first argument here is an arbitrary string. Convention is to specify the module a Celery is instantiated in. In this case, app.py is our simple file, so we're going to go with app. Broker and backend, we specify here. We've got RabbitMQ running as the broker. The backend is Redis. Optionally, you can also use a configuration file, and you pass it in as an object. And this allows for a bit more explicit configuration. And here we're using environmental variables to configure our broker and backend, because obviously this could be different in development and staging and production. And one thing to note that since Celery 4.0, I believe, all this configuration is lowercase, whereas if you look at older configuration files for Celery, it's all uppercase for some reason. OK, so we've got Celery installed. We got a virtual environment up and running with Celery inside it. So we want to kick off a Celery worker. So typically, when I'm developing with Celery, I'll have two terminal windows open. One terminal window will be my Python interpreter. The other or my web server running. The other terminal window will be my Celery worker. So I kick off Celery using the Celery worker command. You pass this. So this app flag here, this is usually one of the first kind of pitfalls or mysteries when people encounter Celery. If you don't get this right, Celery will complain about relative imports, and you'll get some funny-looking output. So what we're actually doing is we're specifying the relative path to the Celery instance from where we start the worker. So for instance, my Celery instance is instantiated in app.py. So I'm going to, from my project root, say, OK, app.celery is the path to my Celery instance. Celery workers start from here. It's easy once you know how it works, but it can, it leads to some confusion the first few times. Again, we're using the -c flag here to specify the number of child processes. This would be a typical output in a terminal window. There's a lot going on here. The things that I'm interested in as a developer is that my configuration got picked up correctly. We've got RabbitMQ, Redis, we've got our app name. And under tasks, I want to know that my Celery tasks have been registered correctly. Here we have two tasks associated with the app module, and that's the add and send email task. And we're going to use those functions, those tasks, in the next few slides to explore how Celery works. OK, so registering tasks. So this is a really contrived and simple function in Python that would be used typically to send an email to a user. For example, when a user signs up to your application. We pass in a user ID. That user ID is used to look up a user profile. And then when we call that function, we call it in a typical way and pass in the keyword argument of the user ID. Converting this to a Celery task is very straightforward. We import our Celery instance, and we use the .task decorator. This wraps this. So you see here, we don't actually modify the function in any way. We just wrap it with this decorator, and when we want to call this in our code, we call it using the .delay method instead of directly. And all this does is that puts that task now onto our task queue. A quick word on state in Celery. Don't pass in anything that's stateful to a Celery task. Obviously, we don't know if this is going to be executed in a few seconds or in a few minutes or in a few hours. So we can't, if we passed in, for example, the user object, we can't be sure that in the time between that user object being passed into the function that that user hasn't gone and updated their email address or they've deleted their account and we're dealing with stale data. So only pass in values, don't pass in objects. OK, so that send email function that we just looked at, that can quite happily go send an email to a user, and we don't necessarily want any return value. We don't want a result from them. So this is another very contrived function, something very simple, where we return the sum of two integers, but we do care about the result in this instance. So when we call the .delay and we assign the output to a variable, this result is not the output of that task, that function. And again, this can be trip new users to Celery up. We're assigning the output to a variable, but we're not getting the return value. What we're actually getting is an async result object. And it's this object that we can store a reference to and use that to look up the result when we try to get the return value. So here is a very simple example where we call this function using the .delay method, and we use the async result.id to look up that task, that specific instance of the task. When we have that result, we can then ask if it is ready, and if it is ready, then we can finally get the return value from that task, from that function. Async result object has a variety of useful methods. Some of the first ones you're likely to encounter is the .get, like we've seen. Things like .successful, .ready can be used to determine in our code what we want to do at certain points if we find out where the task is. .revoke can be used to explicitly take the task off the task queue. And if we use the terminate equals true argument here, we can actually kill execution of that task if it's being executed right now. OK. So Celery tasks have default internal states. And this can be pending, where the task hasn't been picked up yet. Started, the task has been started but hasn't finished. Success or failure, the task has finished in one of those two states, or the task has been revoked. And again, this is similar to how we were getting the result before, but we're actually explicitly asking if the state is one of success, and then we're trying to get the return value. If the state is something else, then we might want to do something else with that result. We might want to wait. We might want to typically poll for the result in Celery. So sometimes those default states aren't enough. This is an example from some source code of ours in ScriptSpeaker, where we have an internal method that can actually determine the progress of our function. What we're actually doing is rendering audio files to disk, and we're trying to calculate the percentage of that is done. So we can update the task state here with this custom state of progress. So we know that that's our custom state. And we actually just put in the percentage done as a float into this state. And then we return that to the client, typically like a web browser. and we can use that to render loading bars, for example. There is an argument for, in some cases, for not relying on Celery to report when tasks are finished completely. In this instance, we're modifying our send email slightly. Our user has this email sent equals false property. And what we actually do, instead of relying on Celery to tell us that that task is done, we're sending the email and actually changing that flag to true. In the case that Celery fails for some reason and it is unreliable reporting the task status, we can do an audit of user profiles and know whether that email was sent off successfully or not. This is a summary of a much more in-depth and great blog post by Dan Poirier of Cactus, and he goes into more detail of why you'd want to do this, some of the scenarios surrounding keeping state outside of Celery and keeping that in your database. Just a quick word on relying on Celery. There's the tasks acknowledge equals task acts late, global variable, and the way the Celery works by default is that it acknowledges the task before it actually executes it. There's scenarios where you actually want to only acknowledge the task after execution, so that if Celery fails halfway through, it will retry that task, and only tell you once it actually is finished correctly. This is good if your tasks are idempotent. You know that you can keep running that task and it's not going to have unwanted side effects. This is one approach to having some increased reliability around Celery. You may or may not benefit from using this approach. Okay. So we've seen some very simple functions as Celery tasks that run in isolation. Sometimes you want to compose more complex workflows and have tasks that depend on each other and work with each other. And Celery Canvas is the Celery API that provides for this. So Celery Canvas uses the concept of signatures, and signature is really just a serializable representation of a task. And this allows us to pass tasks across the wire and use tasks as arguments to other tasks. There's a variety. Sorry. Here we go. There's a variety of default signatures that Celery Canvas ships with. Group, chain, chord, map. I don't have time to go into all of these right now. I will highlight chain because this is something that we've used extensively. And basically chaining tasks means you're linking tasks together in a composable fashion. So we actually, we can then call our functions using the .s, which is short for the .signature method. So what we're doing here, is we're using those add functions from before. We're calling two of them in series using the .s, the signature method here. And what is actually happening is we're calling the first one with the two integer arguments, and the result of this first call actually, or the return value, actually becomes the initial argument for the second. So for example here, 5 plus 7 is 12, so the arguments for the second add call are actually 12 and 10. Again, we call this whole thing using .delay. And then a quick word about getting results out of this. So if we try and get the result as we did before, here you notice I'm using .result rather than .get, but it's the same approach. We're actually getting the final return value, and that's typically the return value from the final executing task. If for some reason we want to get output or the return value of tasks further up the chain, we can traverse using the .parent hierarchy to go up the task chain and look at results internal in the chain. Okay, so you have Celery up and running. We've registered some tasks, and we're using them in our code. So a quick word on testing Celery tasks. Obviously, if you're testing your task, you don't really want to boot up Celery, wait for tasks to be added to the task queue, and then assert some test on those tasks. So good approaches here, you can use the always eager mode of Celery, which actually tells Celery execute everything synchronously. If you just have a couple of tasks in your code base, you can just call them with the apply async method instead of the .delay method. And again, this will call that task or that function synchronously directly. Django has its own Celery test suite runner, which makes some of this a little easier, but that's Django stuff. Okay, so we have Celery up and running. We can test our functions. So now we want to move from development to a production environment. This is shouldn't be as intimidating as it might first seem. We're really using the same core concepts that we've explored so far. The real change here is that we need to run Celery in daemon mode rather than manually. So we need to run Celery in the background. We also need to be able to restart that if something goes wrong. Depending on what OS you're running on, you've got various different demonizing tools at your disposal. Upstart works very well for us. A very contrived and simple Upstart configuration might look like this, where we have a stanza changing to our virtual environment and executing our worker as we've seen before. And we're just respawning on when the server goes down. Okay, so yeah, we have Celery working. We have Celery hopefully running on our production machine. We know how to test, but we don't know how to monitor Celery and see if things are starting to go wrong. So when it comes to logging, again, a pitfall or a common gotcha is to try and pass the root logger from your code into a Celery task and then wait for some logs to happen. This typically doesn't happen. You don't get any output. Celery actually ships with its own logger, which is the preferred way to get logs into your task. We'll have a look at that in a second. There is a way to hijack the root logger. This is not really recommended. You can use this option. Much better to have a dedicated Celery logger. And you can do it per task, where you instantiate a logger for each task. For us, we've always found the best approach is to declare one Celery logger at the beginning of your module and just use that to log out any useful information within your tasks. Again, if you just passed the root logger into your Celery function, you probably won't see any output, and you'll be wondering, where your logs are. Another really, really useful tool is Flower, also known as Flower. This is a really nice web interface for monitoring your Celery processes. It's a really quick way to see what's going on with your Celery workers, how many tasks have executed successfully, and if you have had any failures, it will give you nicely formatted stack traces so you can quickly see what's going wrong with your Celery processes. You can also restart tasks and pools from this web interface as well, and we found this to be too invaluable as your first kind of port of call to know what's going on with your Celery. It defaults to port 555. That can be changed, and you can lock this down if security is an issue. Installing Flower, much the same as Celery, and you start one instance of it. There's no concurrency. Okay, a quick mention to task priority. So RabbitMQ, it does natively support prioritization of tasks, but the best practice here really is to, if you need to have some tasks that are prioritized more than others, dedicate certain workers with the amount of resources that you need. So for example, a high priority worker, you might give it a lot more resources, CPU cores, to execute that work much faster than maybe low-level tasks that can happen in the next few days that you can give that just a couple of CPU cores, and that's fine. Okay, we've obviously talked about Celery here. I would be remiss if I didn't mention there were a couple of alternatives. Huey, which is pure Python, and RQ, which I believe is Python and Redis. I don't have much experience with either of these. I know they work very well, but they are nowhere near as configurable as Celery. OK, so if you don't remember anything from this talk, then pay attention to the last slide. Obviously, if you're designing code that's blocking, you have tasks that block each other, then you're losing all the benefits from having an asynchronous task queue. So avoid this. My recommendation, and you can argue with me about this, is RabbitMQ is a broker, as the best fit, and Redis is a great backend. Don't send objects or any kind of state to your tasks. Keep it values only, and if you need to look up something in the database, do that when the task is being executed. Use the Celery logger. Don't rely on the logger of your application. So one final thought. Do you need Celery? Yes. It does add some complexity to your application. But my experience is that even small web apps that I make these days, one of the first third-party tools that I install is Celery, because as soon as I start doing any meaningful work in my web application, then I'm going to want to farm some tasks and work off to a task queue. So I think that you'll find benefit even for small to moderately sized web apps. Thank you. One note, on my GitHub, there is a small demo project that demonstrates some of these processes in code. Thank you.